Well, again, as Hagit said, welcome. I'm here in Redmond, Washington. It's 7 a.m. there, so I have some cognitive dissonance when I say good afternoon to you in Germany. My name's Dan Cuomo. I'm a principal PM on the Core OS team that runs and works on SMB, on the SMB protocol. It's my first time here at sambaXP, so good to be with you. Thank you for joining. Just move along here. So these are the three presenters here. As you can see, Raymond and Genghis, they're principal devs on the team there, and I'm the principal PM. Our quick agenda here is we're going to go through what came in Windows Server 2025. You may have missed a lot of the things that we did there, so we'll quickly talk about those things, and we'll kind of highlight a couple of them, and then we'll look at an early roadmap and go through some areas of investigation. Sorry if that's coming on screen there. All right. So new to 2025, and if you're familiar with our previous PM, he'd like to have a lot of dogs on the screen, so we figured we'd keep that going. So here's what we shipped in Windows Server 2025. There's actually a lot of different things that changed. And you might be familiar with many of these. Maybe you're not familiar with any of these. We wanted to pull out a few very interesting ones, or the ones that you should be probably a little bit more aware of. But these are a lot of things that changed between Windows Server 2022 and the latest release in Windows Server 2025. A couple of things to call out: the server dialect control. So you can now mandate the SMB2 or SMB3 protocol versions used. This lets you enforce things like encryption or multi-channel and some of the other goodness that comes with the later versions of SMB. We have signing is now required, so we now require signing by default on all Windows 11 24H2 SMB outbound and inbound connections, and for all outbound connections in Windows Server 2025. This kind of changes the legacy behavior where we required SMB signing by default only when connecting to shares like sysvol and netlogon. For the Active Directory domain controllers. SMB signing has been available for decades, and so it prevents data tampering and relay attacks that steal credentials. So we're trying to kind of raise the bar there for attackers that are trying to go after SMB. We have a new auth rate limiter. So the auth rate limiter, it uses the SMB service now throttles failed authentication attempts by default. So this applies to SMB sharing files on both Windows Server and Windows Client. The rate limiter is enabled by default, and it adds a 2-second delay between each failed NTLM or local KDC Kerberos-based auth attempt. So an attack that sends 300 guesses per second for 5 minutes, for example, that would be 90,000 attempts, would now take 50 hours to complete. So we're literally just trying to bore the attacker into trying something else. And then the last one I was going to call out here is SMB server over quick client access control. So SMB over quick client access control lets you restrict which clients can access SMB over quick servers. That makes sense with the name. The legacy behavior allows connection attempts from any client that trusts quick server certificate issuance chain. Client access control creates and allow and block lists for the devices to connect to your file server. So now you have a little more granular access. Can be pretty valuable there as you deploy quick. Just clicking along here. So just going to give you a quick timeline on what the upcoming, many of these features may align with, but I just want to give you a quick timeline to understand how releases for Windows Server work. So in 2024, we had our Microsoft Ignite event in November, and that was where we GA'd Windows Server 2025. The next year, we're here in April. Our next Ignite event will be 2025 in November again. So every year in November, approximately, they have Ignite. Same thing in 2026. And then no later than November 2027 would be when we would release the vNext version of Windows Server. Again, we release every 3 years at the latest. So we sometimes will throw in, an R2 release or something like that, like the year after, for 2025 came out, we could release a 2026 R2 or 2025 R2 or something like that. We have no plans to do any of that. But by 2027, no later than 3 years from then, we will release the latest version of Windows Server, and that would bring some of the new capabilities that Genghis and Raymond are going to talk about in a little bit more detail. So with that, I'm going to pass it over to Genghis, and Genghis, go ahead and take control of the screen there.
So I'll go over a few proposals in the roadmap for optimizing SMB's transport layer. There are a few limitations, or rather unexploited opportunities across transfer patterns that we're not taking advantage of. In spatial locality, many transfer patterns are sequential, and how we do, especially RDMA, we're not taking advantage of that. Ditto with repeated writes to a single region temporal locality, we're not taking advantage of that either. Our proposal to optimize that is to do RDMA better, basically. To exploit spatial locality, use wider registrations. To exploit temporal locality, let registrations live longer, not just within the context of a single I/O. You'll hear the term XMR perhaps used or used before. That's kind of a marketing acronym for better use of RDMA, extended memory registrations. Another proposal to optimize the transport layer is to batch IOs together for a single file. We found through performance analysis there's quite a bit of overhead in the Windows file system stack that could be amortized better if we had batched similar IOs for one file together. Let me quickly recap how we do RDMA in SMB today. For write specifically, we have two different RDMA paths. One is an inline using the RDMA send. It is very similar to how we do sends in TCP, meaning that the SMB command and the payload go together. Or if it's over a certain threshold, we'll use memory registrations, meaning we'll pin the client payload into memory, expose that over the RDMA fabric, and then signal to the server to pull the data over. There are costs per IO with that scheme, memory registration, deregistration, and then signaling between client and server to actually pull the data through. And there's a subsequent slide that'll detail that. We do use FRMRs. These are pre-allocated memory registrations to boost performance, but even with that, there's opportunity for improvement. So let's go over the scheme as it is today. When a payload comes in through the client and let's say it wants to perform a write, we may need to double buffer it. We do that specifically in Windows because we have no guarantees that the buffer will remain invariant or unmodified. So if we have to perform operations related to signing or encryption, we have to have a stable buffer. So that's one cost. Since RDMA ultimately requires physical page pinning, that buffer needs to be locked into physical memory. It needs to be registered with the RNIC. Finally, we have to communicate that registration over to the server, and then the server pulls the data from the client. After the server completes the data transfer, it has to signal back to the client. The result of that operation may have failed or succeeded. After the client receives that signal, it has to clean up. So that's quite a bit of cost for one single IO. So you can imagine if you're doing that for a bunch of IOs to, let's say, a single region, so there's temporal locality, there's quite a bit of repeat work. So to set up to To give us the opportunity to optimize that better, we're adding primitives to the server such that the client on its own can self-manage memory registrations. And with that capability, the client, which is ultimately the agent here, the actor, that has foresight into how IOs will be done in the future, perhaps, it can better plan how it does memory registrations. And perhaps it can let the memory registration live for longer if it has foresight into an IO being potentially repeated for that region. Now, like I've said earlier, a memory registration requires a physical backing. There is a very straightforward way to do that, to hook that up if you have a file system that implements DAX. DAX is a file system mode if it's based up on a backend store that looks like RAM, so these would be NVDIMM or storage class memory devices. So with that backing, ultimately the file system can expose what looks like RAM to upper layers. So using that, you can register the storage area that backs that file directly with the RNIC. Now, these are rare in practice, so we'll have to think of a scheme that can take advantage of the same opportunities in absence of DAX. So this could be better interaction with the OS cache manager to have longer living cache pages. Quick overview of these two primitives that we've added. One is to create a memory registration on top of a file. So you specify a section of a file, the offset and the length, the access rights, read or write. So as I've said, currently we require the file to be backed by a DAX file system. It will query the direct access extents for that region. The result of that will be a list of physical frames which will register with the RNIC. The output of this FS control is a memory registration ID, which is specific to SMB server, and an NDK memory registration token. And then to clean up that MR, you specify the MR ID that you got from the create. The release typically should not fail. It might fail if you pass a security check, if you do not pass a security check. There is special introspection of these FS controls in the SMB client. And the reason that the SMB client needs to do that is if it does receive an IO from the application layer that has an MR registered for that offset, it will perform a direct map IO, aka push mode IO, which we've demoed in previous SDC conferences in 2017 and 2019, Tom and Matthew George. So let's take a look at how a typical write would work with this scheme. A client issues a create a more FS control against an open file. The server handler for that will query the direct extents for that region, set up the MR, do some internal bookkeeping, and then return the MR token back to the client. The client will note that, do some internal booking as well. So that's all recorded, that's stateful. So should a write come in, and if it intersects a range that the client knows has been direct mapped earlier, it will simply issue a push mode IO to that. Otherwise, if there is no overlap with a registered region, you will flow through a regular RDMA path. For a read IO, very similar, except the data flows through the other direction. So one very notable thing here is that in this scheme, there's no labor required of the server. So let's do a quick demo. Well, let's come back to that when it loads. So a few gotchas with the scheme. If we allow the client to self-manage a Mars, you may have a bad actor that will exhaust all the available ORNIC address translation table. So we don't have a good way to solve that. Furthermore, because the server is unaware of writes that are happening, or I/O that happens by the client, it cannot, in theory, maintain last access or last modified type, and based on that, let's say evict unused Mars. It cannot do that. As I've said before, DAX file systems are rare in practice. That requires specialized storage hardware. We are exploring methods to still utilize the scheme in absence of DAX. So one area we're exploring is tightler coupling with the OS cache manager to widen again and keep cache pages for a specific file around longer. Another gotcha or an unsolved problem is write-through and flush, again, because the server is unaware of writes. Something has to explicitly signal to the server that it needs to flush. A client could do that, but it wouldn't be efficient. Or not as efficient as it could be if there had been a special RDMA verb to do that. SMB transfer, specifically compression. Well, I think there was a proposal. SMB transforms, compression, encryption, and signing that require pre-processing or post-processing of a transfer buffer. We don't have a solution for that as well in this scheme. Or rather, we don't have an efficient solution. You'd need to take away some of the benefits to do that. Another thing is that because these registrations live across IOs, they're assigned to a specific ORNIC adapter. So in configurations where multiple ORNICs, which is not uncommon for expensive servers, you'd need to take special care to make sure you go through the right ORNIC. So that'd be Enlightenment and SMB multi-channel to do that. The other thing I mentioned is batching of IOs for a single file. So one problem we've observed while doing performance analysis, there's quite a bit of overhead in the Windows file system stack. There are file system init filters, various locks and resources that have to be acquired, conflict checks that have to be made on a byte range basis. So a proposal to amortize, to improve performance in that path is to batch similar IOs together for a single file. That allows us to essentially amortize that overhead. Some of the locks will only acquire a single time because they're per file. And that will also create further opportunities for optimization down in the stack. If you're familiar with technologies such as bypass IO, this is not a new problem. Especially if you have mini filters such as antivirus and other auditing software in the stack. If you can bypass, that's great, but obviously that could be required by, let's say, corporate policy that every file needs to be scanned. Those mini filters eventually will require enlightenment of these new FS controls, but again, because stuff comes in batched, they could also amortize their own overhead within the mini filter. Write file gather is a Win32 API that allows you to specify an array of buffers to be written contiguously in a single syscall. So batched IO could be thought of as an extension to that, where you can not only take an array of input buffers, but also write them potentially discontiguously. This is something we're currently working on. We've already completed a significant portion of the remote file system stack support for batched IO. Under development are still optimizations in the transport layer itself and better coupling with RDMA. And eventually we foresee this not only as a remote file system call, but also perhaps a generic API at the Win32 level. So let's see if the demo came back. If not, we'll come back to it. Okay, we'll try that third time after. At this point, I'll hand off to Raymond.
All right, thanks, Genghis. My name is Raymond Wang, and I'm the manager for Windows SMB team. I've been working for Microsoft for 18 years, but only started to lead SMB team last year, so 1 year for me. I want to talk about another change that SMB team is doing. It's called block SMB NTLM for Windows application. The reason because this one pretty much works only for Windows application. What's the motivation for this one is, for example, you have some office and you're getting an email which embedded a link to a remote SMB server, right? If you have that UNC path. And you start click on that, and then you're gonna leak your NTLM challenge to if that remote server is bad server. And there's a scenario where the application don't really want to block entire NTLM because until local KDC or other authentication method available, the NTLM authentication still widely being used, right? So there's a scenario where you don't want to block this one for your internal, let's say, network, or where you don't have kernels available. Our primary customer is actually Office team. They want to have this one, where the Office application, email, or some other stuff, they don't want to send this one, give the NTLM challenge to the by server. And the one thing they want to do is to block this one, or if the remote server is over internet zone, right? So there's a something very specific to this internet zone condition. So the way that we make this one work is to use the process mitigation policy. So I don't know if people are familiar with that. If not, there's a API if you look up on the internet, set process mitigation policy, where you can set a specific policy to your process. For example, if Office want to have this one turned on, they pretty much have to call this function and set a specific policy. The policy is going to be some new policy we will introduce. And this policy will pass all the way to the SMB client. And the SMB knows that, oh, you want to block this NTLM for us, then, for the specific process, then it will, before the authentication, they will kind of remove NTLM from the authentication list. Although there is a API to say, to test if a server is over internet zone or not, but there's always some scenario where this test gonna report some false positive. So we're gonna leverage the existing block NTLM server exception list. So basically, if you have a server, you cannot pass that internet zone check. You can put this one in the exception list where you can continue to use that, right? So basically, if you have to allow the access for specific servers, then you can put them in the exception list if you have to. And then the things will still work for you. I guess, NTLM is used more than for SMB. Somebody may also use that NTLM for HTTP, right, for example. However, this feature currently gonna only work for SMB traffic. So it's not about block NTLM entirely for anything for application process. It's just for block NTLM for SMB. So so basically, if anybody choose to use this feature, you're gonna requires an application change. You're gonna have to call this API to change that, and then it will provide some security. Yeah, I think this is maybe I would say probably inconvenient part of this because you're gonna have to modify your application. So that's the summary that includes what Genghis presented. That's the things that we are working on, that kind of a committed feature. Now, I want to talk about the area that we are investigating, or we are, basically try to see what we can do. The reason that we are saying this is investigation is because the business priority or capacity of the team. So there's no firm commitment to that, but we are spending some cycle on the following things. So in summary, those are the multi-factor authentication and POSIX extension for SMB. The first part of this is multi-factor authentication for SMB. Obviously, the motivation is to address security concerns. And there's a government requirement as well. What we learned from our customer is European Union has some government regulation requires MFA, although not in effect immediately. So for MFA, the solution we are investigating, the first choice for us is called Windows Hello for Business. This one is, the reason we are looking at this one as first choice is it's ready. It's ready to use, and it also support disconnected scenario. So disconnected scenario means you can use this completely without any cloud connection, right? So there's some government agency, like maybe CIA or US, they don't want to connect to cloud at all. And they may opt to, or just may, because they could actually use this one as their part of the deployment, right? And still have multi-factor authentication as better security mechanism for their infrastructure. Even Windows Hello for Business, there are still some challenge for SMB team because SMB, the security on Windows is largely connected to, or it's incorporated into the LSAS, the security subsystem, and which is owned by a different team. So any change required in that area, they're gonna need to work with a different team, or alternatively, SMB team may acquire that expertise and change the code in there directly, but that's all requires more capacity or more work for SMB team as well. So sorry, I shouldn't click on. And next one is also in Entry ID. I know Samba community is also have that experimental feature that for Entry ID, but for us, again, that's involve on-prem, any on-prem security authentication that's going to involve the LSAS module that I mentioned that requires collaboration with cross team. But anyway, that's another area that we will spend some cycle as well, and this is probably area we can work with Samba community and to see how the area that we probably can talk to either Entra ID and as well to see the support that we need come from them. And then, well, I guess the third priority, as I didn't really call it third, but just potentially in the future, we're gonna looking into how we can support third-party MFA solution. But this is really gonna be future, I guess. So we're gonna have to, address our top priorities here first. But I would love to have some feedback from communities to see, what you want to see from Microsoft about MFA solution. Next one is POSIX extension. I think Tom already mentioned this one. We will spend some cycle to look at that. From file system perspective, the Windows local file system already supports some POSIX semantics. So it's going to be a little bit easier to address those things for Windows Server, Windows SMB server. Nope. So POSIX mode bits a little bit tricky to do that on Windows file system, but I think there's a way to do that as well. But anyway, in general, this is something we have dev to spend some cycle, but as I said here, there's no specific timeline because the internal resource, bandwidth, and just business priority sometimes. If we have to do something urgent, they're gonna allocate resource to do that first. But overall, those two things, we wanna get some feedback from community about, what you wanna, how would you like to see Microsoft engage or support those features, and maybe have more business justification than to push the priority of those things higher. So SMB team, me and Genghis will be here for IO Lab as well. So if I would love to talk to people if you're interested in provide some feedback on those feature and anything beyond that feature as well. If you want to provide feedback, and you're welcome to find us after that meeting or next couple of days. So with that, I guess that's any questions?